The Chapter 8 of the Eurocode deals with metal fasteners, and it is definitely the most complicated part of the whole Eurocode over timber constructions. There are many different types of fasteners, there are many different types of producers, there are special connections, and there is very little standardizations regarding the producers itself. After opening the sheet, the timber fasteners connection with the metal fasteners is this sheet, so you just double click on it and it opens within a few seconds. Like the other sheet we've gone through, this sheet is split up in different chapters. The first one is the general information, and we have the input data, the results, revisions and license is not so important. If we go through the general information, this part explains shortly what kind of subchapters in Chapter 8 that are dealt with. So we are going right into the input section, which is split up in different parts as well. So we have the general information, which is just a clip out of the Eurocode. The import and export section we already have dealt with in the previous video regarding ultimate limit states. The project data as well. You surely remember that in between sessions NODEMaple stores values in a data table. This data table is in this gray cell. So in case of errors, you will need to push the reset settings button, which will reset this sheet again. So we are stepping into the system section, which is split up in connection and materials and sections. Now the connection is the first part, where you have to define which kind of material is your fastener composed of. And in general you have two material types. You have either timber or you have steel. You have the possibility to have timber-timber connections with inside layers, and you have the possibility to have steel and timber connections. Regarding steel and timber, it is very important that some connections are not possible to have. So if you have, for example, a steel on the outside, then this cannot be used with dowels. In addition, you can't have a steel connection with a zero inside layer connection. So that means that if you have a steel timber connection with just two components, then the steel needs to be on the inside of the component, not on the outside. So if you want to steel timber, you need to have timber and steel here, and in that case you are allowed to have a zero here. So what you're seeing right now is that there are a couple of error messages popping up here, and they always come up because we are going to change some values, and that means that after we have changed the values, then something is not fitting anymore. Sometimes you also get these kind of messages, which is an uncode exception. So okay, we're going back to timber, and we had, I think, one here. Continuing with after the connection settings, we have the general settings of this connection, which is the service class and the load duration class. This must be the same for both parts of the connection, of course. And as we have chosen a timber-timber connection, that means that the steel part of this next input section is grayed out. So we just have the possibility to define two timber parts. We have a solid timber with timber quality C14 for both parts of the connection now, and a grain direction of 0, which means that the beams are horizontal in our case. We also have the possibilities, of course, to define the section values. You can either use the pull-down menu, which uses the pre-stored values which are available in Norway, or you can input the values for yourself. Now, for the first part, which is the outside part of the connection, you see that we also have the possibility to define a second value for the outside profiles. So we going back to that one when we're going through the examples, calculating the examples, which means in principle that the outside thickness of the timber material can be different from the inside layers. So this one defines more or less layers 1, 3 and 5 if you have one inside, and this would define layers 2 and 4. 1, 3 and 5 going in the same direction, and 2 and 4 also going in the other direction, which is defined by these values here. This part here defines the cut of the section, which is more visible in the graphics window afterwards. After we have defined the material and the section, we are going on to the fasteners. Now the fasteners, the first thing you are going to define is which kind of fasteners you are going to use, and there are 4 different fastener types: nail, bolt, dowel and screw. Dependent on the type of the material, the next thing you should choose is the dimension of the material. So we have over 2,000 different metal fasteners in the library database right now, which also means that fasteners which are not defined in the database are not able to be used. So if you want something and it is not in the database, please drop me a line. Probably I can input it in the next revision of the program. So we have the first, number 1 is the type, the second is the diameter of the fastener, and third is the producer, and number 4 is quality. Then we have the length of the fastener, and we have the diameter of the fastener, the diameter of the head of the fastener, excuse me. In addition, it might also be possible that we have a washer. That depends on, again, of this kind of fastener which we have. Again, with the producer and the type of the washer. And it might also be possible that we are going to use a screw with a washer. This orange section here defines special connection types. That might be some kind of shear connectors, like sharp metal, which is solution by Rotoblas. We have the possibility to use split rings. This is according to the Eurocode, and also the same applies to tooth plate. Again, with producer, which kind of type, how many, and regarding split ring or tooth plate, again, which kind of type. This is the Eurocode definition. And tooth plate, if there's a one-sided or two-sided connection. This table here shows the material properties of the fastener itself. The MYRK, the moment resistance of the fastener, the axial capacity, the capacity of the head, and the tensile capacity. For other stuff, it might be interesting to have the internal diameter and the external. This is regarding the washer. And also the capacity of the washer regarding the material, the timber material. Next part is the geometry of the fastener, which defines in which kind of grid or geometry the fasteners are going to be placed. So you can also define different kinds of fastener patterns. So you might use a predefined pattern, or you might define your own and save them. In general, there are 2 possibilities. You could either have a grid, which is a rectangular, more or less, where the center of the grid is defined here, not only of the grid, but also of for the rotational, the circular fastener patterns. Then you can use a kind of definition which is similar to that one which Tekla also uses. So you can have 2 by 60. All units here are millimeters. So we have 2 rows with 60 millimeter distance in the X direction, and 1 row with 36 millimeters in the Y direction. It is also possible to have a screw inclination. This one will be shown in the examples in a future video. You can also have a radial kind of geometry, and you can also mix between grid and radial if you want to. Okay, we're gonna have lots of error messages here because minimum distances might not be fulfilled here. Third method to input fasteners is by using coordinates. So you can put the x and y coordinates of each of the fasteners in this box here, and then they will be used. An additional checkbox here is you can either calculate the forces on the fastener or you can calculate the reaction forces on the fasteners, which means that the sign of the vector is going to be switched. Some other checkboxes here include if a row is parallel to the grain 1 is staggered, which means, especially for nails, then there are different kind of minimum distances if there is a staggered placement of the fasteners. You can also check if the fastener is pre-drilled or not. If there is a pre-drill requirement, you can also switch this one on, which means that the pre-drill requirement can be ignored. This one actually is not active at the moment. This defines the angle of the screw compared to the surface of the screw. Next part shows the minimum distances of the section you have defined now, and if your placement of the fastener is going to fulfill the minimum distance of this fastener requirement. So this one shows the unfavorable minimum distances for this kind of fastener you have chosen. This one is calculated according to the force on the connection. This one is the calculated minimum distances. Figures that are green are okay, figures that are red are not okay. So we have this for timber type 1 and timber type 2. It's also going to check for steel if you have a steel connection. Next part is the load definition. Again, you can have you have an explanation about what these forces, how they should be defined. And again, you can have different load cases, either numeric or alphanumeric. These one are the characteristic definitions again with these predefined load safety factors, or you can enter the dimensioning forces directly. The coordinates of the load center are also interesting because you can choose where this force is acting upon the connection. This one is a very special case here. It's according to the part 814 in the Eurocode, which is a tension normal to the grain, and this is a factor reducing the defined shear factor. If you multiply the shear factor with this one, this value is then used to define the utilization according to checkpoint 814 according to the Eurocode. The last one is the result section again. So you have the possibility to do automatic calculation with all load cases. We also have a special check for 814 according to the German NX of the Eurocode. We're going to talk a little bit more about that one in the example section. So in that case, we have a calculation is for load case 1, and you have a lot of information about what is calculated in this calculation. So we have a no overlap fastener solution, Eurocode 6.2 check net section, no double-sided connection, FVK according to 822, formula G to H, and it is as a dowel calculated as a dowel pre-drilled, and the F10's K value is calculated. If you have a red box here with an alert, that means that the calculation is not valid at the moment. So either it is simply aborted or the results might not be correct, because in that case, warning A for 1, which is the minimum distance for 1, the distances below the required minimum distance, and also A42 distance below required minimum distance. The other values here are the utilization factors according to the different parts of the Eurocode. This is for the active part, and this is for the most critical load case of each of these parts. So we have a check for code 812 for check according to Eurocode 832, 814, 833. We have the net section active, and we have according to Annex A, and we have the bolt steel, and we have the worst of these utilization factors listed here. Red is bad. The next thing is dealing about the forces. We have an own spreadsheet which I'm going to talk in a different video about. The calculation of the forces is shown here, and the distribution of the forces here as well. So we have the current load case here is 1,3. We have a force of 11.18 kilonewtons on the worst fastener, which is going also in the x direction with an alpha angle of 0 from the right horizontal line upwards, and also the x and y coordinates of the fastener, which is the critical one. The graphics are going to be updated if you don't have any red values in this alert section here. So it could be possible that they are going to be updated. We can try. But probably, yes, it's going to do that, but it might not do that in all directions. So you have, in all calculations, so you have the possibility to add annotations, you have the possibility to add distances, which is going to show you the minimum distances of each of this fastener. You have two beams, in that case the yellow one and the green one, and this section is the overlap between those two. So we have the A3 is the distance from the bolt to the end of the beam, in that case beam number 2, and we have A31 is from the fastener to the end of beam 1, and you have the A11 and A2 values here, and the A4 values to the side of the beam. The grain direction is in that case here. Additionally, you also have, if I put that one back again, we have the notations, which gives you the numbers of the fasteners, and it gives you the center of the fastener as well, which is here, and also the center of the force, which is defined here. So you have the center of the fastener and the center of the force. We might also have a block shear. Block shear is not shown probably here because we don't have a steel connection. Block shear is just shown with the timber steel connections. And you have the forces as well. You can change the size of the forces by using that slide on the left hand side. So that was almost everything. No, it is not. The result details, of course, again, stuff which is shown as white is valid. And for each of the calculations there is a section. So you can have your own calculations and check the results here if they are correct or not. So you have for section 814, for section 62, steel and bolts check, block shear and block shear failures, 822, the different values from formula A till M, the alpha rope factor, tau factor, and 8 to 10. So that was a very quick introduction for the connections with metal fasteners in NODEMaple, and I hope you see you next time in the next video.